computer science video with me, Mr Goff, for MrGoff.com. This video will focus on graphs. A graph is an abstract data type that can be used to represent complex relationships, such as the roads connecting towns, or the relationships between users on a social networking site. A graph is made up of nodes, sometimes also called vertices. This would be the towns in the first instance, or the users in our second example. It's also made up of edges, sometimes called arcs, which are the relationships between these. In this case, the roads connecting towns, or the relationships between different users on the social networking site. A graph can be either directed or undirected, depending on whether it is representing a one- or two-way connection. In an undirected graph, all connections are bidirectional. That is, you can move between the nodes in either direction. If all the edges in a graph are one-directional, then it is a directed graph, or digraph for short. A weighted graph can provide additional information about the connections. If we stick with thinking about links between towns, it may be values of distances, time to travel, or even public transport prices. Other uses of graphs include social media connections, knowledge graphs such as the hyperlinks between topics in Wikipedia, web pages and their links, and many more examples. An adjacency matrix is one way to implement a graph. This can be represented with a 2D array. Each column heading is a node. A value at the intersection of two nodes represents an edge between them. As you can see, going from A to B will cost 7, same as if you go from B to A will cost 7. The advantages of an adjacency matrix are that it's easy to work with, as it's really just a 2D array, and it's easy to add, edit and remove edges. The disadvantages of using an adjacency matrix are that a graph with many nodes but few connections will take up a lot of extra space in memory. It's also hard to add and remove nodes. An adjacency list is another way to represent a graph. It's the more efficient way to represent sparsely populated graphs. A list of nodes each linked to their list of adjacent nodes, and for weighted graphs their edge weights, is what is stored. You can see this example here for this directed weighted graph. As you can see in this example, starting with A, which has two connections that can be followed outward to other nodes, the adjacency list shows all the other nodes that you can visit from a particular node, along with their particular edge weight. That brings us to the end of this video on graphs. Join me again soon when I'll be looking at a special kind of graph called trees. Use the resources at MrGoff.com to help you revise computer science. And until next time, it's bye for now.